Today we're going to get started with section 4.5 of our math analysis book, which is on graphing the sine function. So the last couple of sections we're going to be graphing sine, cosine, tangent, a little intro to cosecant, secant, and cotangent. But today we're going to focus on sine. So I attached for you guys notes on 4.5 graphing sine. We're going to be using this if you want to get that out on your phone or on your tablet so we can edit. Okay, so this is what it looks like. Okay, and I'm going to show us a couple things on the computer to start with. So this is my website, and I have a few things I want to introduce to you guys here. So we talked the other day, this one here is the one that practices the unit circle. It's a little unit circle game, okay, where it asks you, if you start the game, it'll say, okay, where is pi? So here I would put pi because it's the same as 180. Okay, where's negative 1/2 comma root 3/2? So that would be short, negative, long, and so we're going to go to the coordinates, okay, like that, 0, 0, and so forth, okay. I also had shown you guys on my website where it says more unit circles. Okay, I have half of the unit circle drawn out. Here is that same one I just showed you, and here's another one. Now, this one here has the degrees already marked. This one here does not, so it's a little extra practice. Okay, so you would put your radians here, you would put your degrees here, you would put your coordinates here. Okay, so just as an example, here it says 45 degrees. Okay, so 45 degrees, I would come here and click there. Root 3/2 comma negative 1/2, so that's going to be long positive, short negative, so that's going to be right here, and so forth. 3 pi halves, that would be a radian. Okay, here's your degree, here's your coordinates, so radian would be right here, and so forth. So that's there for you guys, okay? Something else that's here for you guys is unit circle to graph. So I'm going to click that, okay, on this unit circle to graph. It shows you the sine, the cosine, and the tangent. Going around a unit circle. So this blue one here is our cosine, the green one is our sine, and this gray one is our tangent. Okay, now I'm going to come over here to the unit circle. Okay, and I'm going to get the coordinates out so we can see the coordinates around the unit circle. The ones we're really going to focus on is 1, 0, 0, 1, negative 1, 0, 0, negative 1, and 1, 0. Those are the nice ones to plot. I don't want to have to plot a root 3/2 comma negative 1/2 or root 2/2 comma root 2/2, anything like that. Also have the quadrants here so you guys can see the quadrants. Angles, but instead of having it in degrees, we're going to have it in radians because we're going to be graphing this in radians, okay? Now, again, I want us to focus on, and let's see if I can do this. Give me one sec. Okay, so we're focusing on this one right here. Okay, can you kind of see it? Of course, I'm in blue. I shouldn't be in blue, so let me erase that. Okay, let me get a green so we can get green, and let me get it a little fatter than that. Okay. And again, I don't want the eraser. Okay, so let me grab my draw again. Draw, and I'll get it a little fatter. Okay, so we're following this one right here is the one we're going to be looking at, okay? That's going to be our sine graph. Okay, so let me get out of this and let me come back here, okay? And now I'm on the unit circle. You see my cursor? So I'm at 1, 0. Now when we're graphing sine, we're graphing the y coordinate. So I'm graphing 0. And then when I get up to the tippy top of this, I'm going to be at a height of 1. And as I continue around, again, I'm looking at the y coordinate. I'm going to be back at 0. I'm on the x-axis. And as I go again, I'm going to be down at -1, okay, below the x-axis. And then I'm going to be coming back up to 0. So again, let me get my cursor over here. I'm following this one in green, okay? That is my sine. That's what we're graphing today. And so you can kind of see as I move around the unit circle where I am on my sine. It also shows, again, in blue, the cosine, and in gray, the tangent, okay? Something else I have on this website, let me undo this line in the middle, sorry. Erase, okay. So on my website here, we have Desmos, okay? But I also have this one I call trig function Desmos. It's really just the same Desmos, but what I did was I made the x-axis in radians, okay? You can always change that up here if you go to the wrench. You can change how you're labeling things. You can see I'm going by pi halves. Down here I have radians, okay? But this is already in radians for us. So now I'm just going to real quick show you guys what I'm going to be graphing. Y equals sine x, okay? You can see it again here on this graph. Let me just move this so we can kind of see it. And what I want you guys to focus on is here, I'm going to start at 0, okay? This was starting at the radian 0, my height was 0. Then when I went to pi halves, top of my unit circle, my y coordinate was a height of 1. Then at pi, I went back to 0. At 3 pi halves, I was down at -1 on my unit circle. And at 2 pi, I was back at 0. So you see how you start at 0, you end at 0. You have 0 in the middle. And then in between these zeros, I'm going to be up at 1. And in between these zeros, I'm down at -1. Again, I'm following the unit circle. Now, you'll see that this continues forever and ever in both directions as I move it, okay? We are going to be focusing on one cycle of it, one period, and what you'll notice is that once I get here to 2 pi, I'm going to continue going the same way that I just started. So I was at 0, 1, 0, -1, 0, 0, 1, -1, and then I'd go back to 0. So our sine graph, which is going all the way around the unit circle, has a period of 2 pi unless it gets adjusted. Something else I'm going to show you, I like to put in y equal 0, and let me just change it. I'll change it to, hold on. You just hold it, you can change it. I'm gonna change it to an orange so maybe it sticks out a little more. Okay, so I like to always draw in where my center is. My center is where my zeros, and it's not on me right now. You can't see me, but I'm really kind of doing air quote zeros. Your 0 may not be on the x-axis. It is the center vertically of your graph. And so you can see I'm going 1 above this, and over here I'm going 1 below this. The max that your sine will ever be is 1. The minimum your sine will ever be is -1 if you ever take sine or of any number. Now, when I can change that stretch, okay, we're going to see that when we're graphing it. So that can change if I have what we call an amplitude, kind of again like a stretch, and it can be making it go higher and lower. But if it's a plain sine, the maximum is always 1, the minimum is always -1. Okay, so let me get back to this. And this is, again, that worksheet that I gave us for notes. And again, sine and cosine are on our unit circle, right? They're x and our y. We care about the y, we care about the sine. So as I'm going around the unit circle, here at 0, my sine, my y is 0. Here at the top at pi halves, it is 1. Over here at pi, it's back to 0. Over here at 3 pi halves, it's down at -1. And then let me just kind of add this in. I actually have it coming back here to 2 pi, and it is 1 comma 0 again. Let me make that a little thinner. It's a little. So this is going to be 1 comma 0 again, and I'm coming back here. These are the 5 points I'm going to be graphing every single time with maybe a little adjustment, but those are the numbers we want to be thinking of. So let me just jot them out here. Okay, so again, I'm going to start at 0, height of 0, a little fatter, height of 0. I go up and I'm going to have a height of 1. Then I come back here and I'm at 0. And I come down here and I'm at -1. And then I come back here and I'm at 0. These are the 5 points I'm going to be graphing. I always need 5 markings when I'm doing my sine or my cosine graphs, okay? So the 5 markings are 1, 2, 3, 4, and back here is 5. So where I start at 0, but I end all the way back at 2 pi, which are the same coordinates. And those are the 5 I'm going to be graphing. So here, again, these are the nice values around the unit circle. 0 was 0, pi halves was 1, pi was 0, okay? 3 pi halves was -1, and 2 pi is 0. So 1 cycle around the unit circle, okay, is equal to the period for our sine graph. So regular sine, nothing done to it, no adjustment, nothing, no translation or anything like that going on with it or stretch, has period of 2 pi, okay? Same with our cosine, we're gonna see down the road, but today we're focusing on sine. Now, what we're going to be doing is we're going to be graphing this, and I'm going to be talking about some of these, and then eventually I'm going to be defining these on the next page for us, okay? Now, your amplitude in this case is how high above or below the center you go. In this case, this was our regular sine that I just showed you, and this had an amplitude of 1. So I'm just going to change that, give it a little, okay, that had an amplitude of 1. Now my vertical shift, okay, normally I'd have my center here, okay, and my vertical shift would be moving up and down. This doesn't have a vertical shift, so we're going to say none. The period, again, might be adjusted, but in this case, it is a basic sine, and the basic sine graph is 2 pi. Phase shift. Phase shift is kind of like your horizontal shift, where you're starting from, okay, shifting it right or left. In this case, this is regular sine. It's not going to be shifted, so this is none. Now, when I graph my sine graph, I like to get, usually if I was doing this on paper, I would just take a highlighter, a yellow highlighter. I'm going to do this with a yellow pen on this. I'm going to get one a little thinner so it's not too, I thickened it up a little bit. Okay. So I'm going to draw this. This is where my center vertically of my graph is. It's going to be on the x-axis in this case, okay? And I'm going to draw 1 cycle of this. I'm going to zoom in a little bit more. And so when you're thinking about a unit circle, and let me just draw a unit circle up here, just as a little reminder for us, okay? So I'm only going to be listing my y coordinates because that's the ones I care about. Here, I am at a height of 0. Here, I'm at a height of 1. Here, I'm at a height of 0. Here, I'm at a height of -1. And then when I get back here, I'm at a height of 0. So again, those are the numbers I'm going to be graphing. 0, 1, 0, -1, and back to 0. 0, 1, 0, -1, 0. So at 0 radians, my sine value is 0. My y value is 0. At pi halves, I'm up here, my sine value is 1. Over here at pi, my sine value is 0. And down here, my sine value is -1 at 3 pi halves. And then this is 2 pi, the 2 pi part, the pi part came off, 2 pi. Then I'm back to 0. And let me draw that. And that is one cycle, okay? I'm showing one period of the sine graph. And again, we're going to constantly be graphing these 0, 1, 0, -1, 0. Okay, we start at 0, we end at 0, we have 0 halfway in between, and in between these, we're going to be going 1 above, in between these, we're going 1 below. And that's your sine. And again, it continues, but we're going to graph one cycle. Okay, so now, the amplitude is, and this is absolute values, okay? In absolute values, how high above and below the center. So really our sine graph, we can always kind of start it because it continues forever and ever and ever in both directions. So we can kind of start wherever we want. So we don't care about it being a positive or negative amplitude, except for when we're going to start somewhere and graph from there. We care about how high above or below without it being a positive or negative. Just think of it as the positive. So in absolute value, vertical shift is how high up or down the graph has been translated. And it's going to take that yellow line I just drew and it's going to move that whole center, which would have my zeros on it, up or down. 2 pi is what the length of regular sine is. That's the period, I should say, like the one cycle of sine is 2 pi. But sometimes that can change. So this B we're going to see is going to be adjusting that. Okay, B is going to be how many cycles or how many full cycles of sine are within 2 pi distance. It may not be from 0 to 2 pi, but within 2 pi distance. And we'll see that in a minute. Phase shift. That's kind of like your horizontal shift. How far to the left or right of the graph has it been translated? Okay. So let's take a look at this one here. Okay, y equals sine x plus 2. And let me get, for you guys, this again. So this was our sine, okay? Now I'm going to be entering in y equals sine x plus, oops, forgot my n, sine x plus 2. Now, what you'll see is it's the same exact graph as this, but it got adjusted. This is starting here at 0, and this is starting here at 2. This whole graph got shifted up 2. So instead of having my y equals 0 as my center, for this graph, I'd have y equal 2 as my center. Okay, let me just get rid of looking at that one for a second. And so you can see here is my y equal 2. I'm still going 1 above, okay? I'm still going 1 below, but since I'm starting at 2, when I go 1 above, I'm at a height of 3, and when I go 1 below here, I'm at a height of 1. So when you have this plus 2 here, that's going to shift your graph up 2, okay? So in terms of this, okay, let me go through all of these terms again. Amplitude, right now, we saw that it was just the amplitude of 1 because it was going 1 above or 1 below my center. Vertical shift up 2, okay, because of that plus 2. Period was still 2 pi, that did not get adjusted. And our phase shift is none, okay, we still start in the same spot. So with this vertical shift, I like to always start by drawing that in. So I'm going to come here to 2, and I'm going to draw that in. Okay, that's where my zeros are going to be. Okay, so again, remember, we graphed 0, 1, 0. Okay, that was on the top half of the unit circle. Then we went back down to -1, and then we went to 0. Those are the numbers I'm graphing. Okay, so at 0, I'm at air quote 0, but that's really at a height of 2. And then at pi halves, I'm going 1 above that center. And at pi, I'm going back to my 0, which is in this case 2. And then I'm going 1 below at 3 pi halves, okay, because I'm going -1. But if I was at 2, now I'm at 1. And then at 2 pi, I'm back to 0. And this is our sine x plus 2. And again, I'm just doing one cycle of it, okay? Okay, so again, that one, the +2 moved our graph up, okay? That was our center. So that's what that +2 does. So now the next one, we're going to see what the 2 in front does. So let me switch back to the screen so we can see this. So let me get rid of this. Okay, let me change this back to 0, okay? This was our regular sine graph, okay? So now I'm going to enter in y equal 2 sine x, okay? And just a little note, if you hit the keyboard down here and you come over to functions, they do have all of them here you could pick from also if you didn't want to have to type it out. Another option. Okay, so here is in green, okay? Now what you'll notice is it's here at 0. All the zeros are the same. What has changed was here when I was at pi halves, comma 1. Now I'm at pi halves, comma 2. It's twice as high. Here when I was at 3 pi halves, I was at -1. Down here at 3 pi halves, I'm at -2. So this 2 in front here, this is your amplitude. That's making it twice as tall above the center and twice below the center. Okay, so let's try that one. So we're going to come back to this. And again, our amplitude is this 2 in front. That is our amplitude. Vertical shift, we didn't have any, so that's going to be none. So we're going to be centered on the x-axis, okay? Period, it didn't change our period. That was also still 2 pi. And we didn't have a phase shift yet. We haven't seen that yet. So I'm going to start by drawing in my vertical shift, which there is none. So I'm going to be drawing this on the x-axis. And then again, remember, normally I would be plotting 0 and then 1 and then 0 and then -1 and then 0. But what's going to happen is this 2 is really doubling, timesing each of these by 2. But when I times my zeros by 2, I still get 0. When I times this by 2, I get 2. And when I times this by 2, I get -2. So let me just kind of go like this. Okay, so here at 0, I'm still at 0. At pi halves, I would have been at 1, but now I'm going to be up at 2. At pi, I'm back to 0. At 3 pi halves, I would have been at -1. Now I'm at -2. So again, I'm going 2 above. And here I'm going 2 below. That's because of that amplitude. And then I'm back at 0. And that's y equals 2 sine x. Okay. So the +2 afterwards and the last problem shifted it vertically. The 2 in front changes our amplitude. Okay. Let me just zoom in a little bit more so you can see again, this is 0, pi, 2 pi. Okay, so our next one. Okay, we have x plus pi halves in it. So let's see what that's going to do to our graph. So let me get rid of this one, okay. So we have y equals sine x as comparison. So now I'm going to do y equal sine parenthesis x plus, and then to get my pi, I can come down here and let me get my cursor, sorry. And here is my pi, and whoops, I want it inside. Okay, so x plus pi, and if you do division, it automatically changes it to a fraction, okay? Pi halves, okay? So now what you'll notice is my sine graph normally has its 0 here at 0. Okay, I'm going to get rid of this for a second. Okay, so again, it's usually here at 0. Now, what's happening is normally sine should go up 1. But if I come over here to negative pi halves, you see that here at negative pi halves, then I'm going up to 1 here. So the shift was a horizontal shift. Whatever makes this parenthesis 0, that's where my new start is. When I say start, I mean that's where normally like my 0, 0 would be, is now there. okay? So let's get back to this, okay? Amplitude is still 1. They didn't do anything to that. Vertical shift, none. Okay, I'm just shifting it horizontally. Period is actually still 2 pi. We haven't seen a period change yet. And phase shift is negative pi halves. So basically what this means is we're going left pi halves. Okay, and that's where we're going to start. Okay, so everything got shifted over 1 pi half. Let me get my vertical shift in here, which there wasn't any, so it's at y equals 0. And again, I'm still plotting my 0, 1, 0, negative 1, 0. Those are the 5 I'm plotting. I'm going to be starting here at negative pi halves. That's where my 0 is. Then when I go pi halves more, I'm at 1. When I go pi halves more, I'm at 0 again. When I go pi halves more, I'm at negative 1 and at 3 pi halves. Now, sometimes depending on the period and the start, sometimes what I like to do, I'm just doing it in a different color, is if I know I'm starting at negative pi halves, I add the period onto it, and the period happens to be 2 pi. So I know like where my start is and where my end is. Okay, now 2 pi, if I rewrite it in terms of halves, is negative pi halves plus 4 pi halves. So when I add that together, I end up with negative 3 pi halves, which is where my graph ended, okay, at negative 3 pi halves. So sometimes I like to know my start and stop are, because those are going to be my zeros. Halfway in between is going to be my 0. Halfway in between those is going to be a 1. Halfway in between these is going to be my negative 1, unless I have a different amplitude. And that's my graph. Okay. So far we have seen a vertical shift. We've seen a horizontal shift or a phase shift above. We saw an amplitude being changed. Now we're going to try to see what happens with this too. So let me go back to Desmos. Again, I'm using the trig Desmos that from my website. Okay, so I'm going to change this to a 2x. Okay, so what I want us to notice is here, okay, they both are starting at 0. And notice I have my 1 here, my 0, my negative 1, and my 0. So what happened was I did a whole cycle by the time I got to pi. And then if I continue, I'm going to have another cycle until I get to 2 pi. So this 2 in front of the x is really telling me that I have 2 complete cycles of pi within 2 pi distance. Okay, that's really what that means. Okay, let me get rid of this one for a second. So again, let me get, okay. So I've got 1, let me get my pen, hold on. Format. Actually, I want the draw, sorry. I'm using the wrong one. Okay, so as I'm coming here, this is 1 whole cycle, okay? And let me get a different color. This is another cycle. So I have 2 cycles within 2 pi distance, okay? Okay, so now let's get back to the other screen and let's do this. Okay, so I have just a regular amplitude of 1. My vertical shift, I had none. My period, and this is how you figure out your period, okay? So in this case, my B is 2, and period is equal to 2 pi, because that's what a normal cycle is. So 2 pi over 1, I have 1 cycle in 2 pi. But now my b is not a 1, it's a 2. And so I divide it. Here, let me write out the formula here. Let me put the b here. Okay, so that means 2 pi over 2, which is pi. So I'm going to be going from 0 to pi. That's going to be 1 cycle. Okay, so again here, let me write 2 pi over 2 is what I worked out, but that is pi. Phase shift in this case, we have none. Okay, so I'm still going to be graphing my 0, my 1, my 0, my negative 1, and my 0. But I'm going to be starting at 0 and ending at pi. So the way I like to think about it is if I'm not just going from 0 to 2 pi and I'm adjusting it, I know I'm starting at 0. Oh, here, and let me also draw in my vertical shift, which I don't have any. That way I'm always staying focused as to where my 0 should be. Okay, I like to always do that. Okay, so here's my 0. That's my start. This is my end. When I have sine, I start at 0, I end at 0. And halfway in between is 0. And then halfway in between these is going to be a height of 1. And halfway in between these is going to be down at negative 1. Okay, so let me just kind of zoom in. Okay, so I went 0 and pi. Halfway in between at pi halves, but halfway in between, I don't even care if we know what that is. Halfway in between is 0. Halfway in between those, which would be a pi force, but again, I don't really care. It's 1. Halfway in between these is negative 1. And we're going to graph it. And that's our graph. Okay. Now, I just want to show you, and I'm going to do it in a different color, that if I was continuing this, okay, again, I start here at 0. I'm going to have my zeros here. Okay, I'd be going up 1, I'd be going down 1, and you see that would be my second cycle. So I have 2 cycles from 0 to 2 pi. Okay. So now let's take a look at our next one. Okay, now this is our formula, and this actually should have had parentheses around it. I have to make an adjustment on that. That should have had parentheses around it. So this is y equal a times sine b of x minus h, right, sine b times x minus h plus k. A is our amplitude. The b is how many cycles you have, and just let me remind us that period equals 2 pi divided by b, okay? H is our horizontal shift or our phase shift, okay, whatever makes that 0, and k is our vertical shift, okay? So we're going to try a bunch of these, okay? We're just going to run through these. So on this one, my amplitude is, I have a -3, so I have to be careful. I'm going to be going, if it's negative, instead of going up, from 0 going up 1, I'm going to be going down, okay? So my amplitude, though, is 3 because we always want to think about it in terms of absolute value. No vertical shift, so this is none. My period, regular 2 pi because nothing's happening in front of my x. And my phase shift, again, none because it's not an x with a parenthesis that anything's happening to it. So I'm going to first draw my vertical shift, which is 0. Okay, now what's going to happen is I'm still going to be starting at 0 and ending at 0 for 2 pi because it's still 2 pi. Halfway in between is still my 0. Now, where I need to be careful is, again, normally I would be doing 0, then 1, 0, -1, 0. But this -3 is going to change it, okay? So what happens is, let me just do it in a different color. So this becomes, not yellow, that was going to be color to write in. So when I multiply this by -3, I get a -3, this 0, this by -3, I get a 3, this by -3, I still get a 0. So these are the heights I'm going to be going at, okay? Now let me just kind of get that out of our screen so we can see where we are. Okay, so I am going to be going halfway here, down 3. Normally I would have been going up, but because of that negative amplitude, here, halfway in between, I'm going up 3, and there's my graph. Just want to get rid of that dot. Okay, there's my graph. Okay. So now the next one, we have a lot of things going on here. So let's take a look at this. Okay, so in this case, nothing in front, so our amplitude is going to be 1. Vertical shift, that -2, so we're going to go down 2. So -2, okay, which means down 2. So let me just draw that in before I forget to. So I'm going to be down here at -2. This is going to be the center of my graph. I always like to draw it in. That's where my zeros are going to be. My period, well, there's no number in front of the x, so that's going to still be a 2 pi. And then my phase shift, what makes this 0? Well, -3 pi halves. So that means I'm going to start at -3 pi halves. Now, again, it's nice to know where I'm starting and stopping. So what I'm going to do is I'm just going to jot this down here. I'm starting at -3 pi halves, okay? And I'm going 2 pi. Now, what is 2 pi in terms of halves? Well, that's a -3 pi halves plus 2 pi is 4 pi halves. And that becomes pi halves. So I'm going to be starting, this is my start, this is my start, this is my end. So I'm going to be starting at -3 pi halves and ending at pi halves, okay? So let me come up here and let me just get the equation in there so we can see the equation. There you go. So I'm going to be starting at -3 pi halves, okay? So this is -3 pi halves, that's my 0. I'm going to be ending at pi half, which is here, okay? Now halfway in between, okay, so if I go 1, 2, 1, 2, and halfway in between, I'm also at 0. Again, my amplitude is 1, so halfway in between those, I'm going to be up at 1. Halfway in between these, I'm going to be going down 1. And there's my sine, okay? Okay, so now this next one here, okay, my amplitude is going to be 2. My vertical shift is -1, so I'm going to mark that right away, okay? So I'm going to be down here at, and this is what I like to do. I like to always have marked where my center is, where my high is, where my low is. So my center is going to be at -1. I'm going to be going 2 above. Okay, so that's going to put me at 1. I'm going to be going 2 below. That's going to put me at -3. Okay, I like to know my middle, my high, my low. So now, period, well, that 4 is going to adjust my period, okay? So let me just kind of jot it over here. It's going to be 2 pi over 4. So what's happening is I'm having 4 whole cycles by the time I get to 2 pi. So that means my period is really pi halves. And my phase shift, none. Okay. So I'm going to be starting at 0. I'm going to be ending at pi halves. Now, they don't have the scale for us, so what I'm going to do is the following. Okay, let me just get a black pen here. So let's just say that this is pi halves. Okay, so I'm going to mark every 2 just to have it not so scrunched. Okay, so pi halves, pi. And so again, this is pi halves. Okay, this would be pi. This would be 3 pi halves. Okay, but again, I would mark my start and my stop. Okay, so I just want to make this a little smaller. I'm running it kind of big. I'm just going to zoom in for a sec. So this is pi halves. And we always need 5 marks. Okay, we have our 0, our 1, our 0, our -1, our 0. So 1, 2, 3, 4, 5. Okay, so I am starting at pi halves. I'm going 2 pi away. Now 2 pi is 4 pi halves. So I should be at 5 pi halves. 1, 2, 3, 4, 5 pi halves. I am 5 pi halves. Okay, so that's my start. This is my end, 5 pi halves. Okay, and let me draw in. I didn't draw it in, I put in a number, but this is my vertical shift. And then I'm going to be going to start at pi halves. So this is my 0. I'm going to be ending at 5 pi halves. So this is my 0. I'm going to be going halfway in between. And then from here, my amplitude is 2. So halfway in between, I'm going to go up 1, 2. And halfway in between these, I'm going to go down 1, 2. And there's my graph. Okay, so this one I do have a negative in front. Okay, so my amplitude is 1, but again, it is a negative, so I need to pay attention to that. My vertical shift, that +2, so I'm going to be going up 2. My period, I have this 3 here, so that's going to be 2 pi divided by 3, which is 2 pi thirds. So I'm going to have one whole cycle within 2 pi thirds distance. And I'm going to be starting not at 0, but at pi halves, because pi halves makes that 0. So the first thing I'm going to do is I'm going to just figure out where I know I'm going to be starting at pi halves. Where am I going to be ending? Well, my period is 2 pi thirds. So I'm going to be adding this together. Okay, I'm just going to kind of scooch this down and write a little above this. So these are both 6. So this would be changed to 3 pi 6. This would be 4 pi 6. So I'm going to be ending at 7 pi 6. So I'm going to be starting at 3 pi 6. And I'm going to be ending at 7 pi 6. Okay. So let me just mark 1, 6, 2, 6, 3, 6, 4, 5, 6, 7. Okay. So I'm going to be starting here at 3 pi 6. I'm just going to zoom in for a sec, make it tiny. Okay, so this is 3 pi 6, and I'm going to be ending here at 7 pi 6. Okay, that's where I'm going to be starting and stopping. And we're always plotting 5 values, 1, 2, 3, 4, 5. Now, this had a shift of being up 2, so I'm going to be starting up at 2. My amplitude was 1, so it's actually, I'm going to be going down first, but I'm going to be going up and down 1. So I'm going to be basically between 1 to 3. And we get my vertical shift in. That's my vertical shift. Okay. Now I know that I'm going to start here. I'm going to end here. And halfway in between, which would be here, is another 0. And then again, I'm going to, instead of going up 1, I'm going to go down first. So I'm going to go down 1. So this one, I'm going to go up 1. And there's my graph. Okay. Okay, so on this next one, I'm going to get a different color. So different colors in between these, just so they don't all blend. So here, my amplitude is 4. A little pattern. My vertical shift, I don't have one because there's nothing here, so this is none. So that means I'm going to be on my x-axis. My period, and this is where you want to be careful. This is going to be 2 pi divided by 1/2. But if you want to think about it, within 2 pi distance, I have only done half of a cycle. So it's going to take another 2 pi to get the whole cycle. So 2 pi divided by 1/2 is really 4 pi. Okay, so it's going to make it stretched out. Okay, phase shift, what makes this 0? A negative pi thirds. So I'm going to be starting at negative pi thirds. I'm going to be adding 4 pi onto it. Okay, so the 4 pi, I could rewrite 4 pi as 12 pi thirds. So this is really just a fancy 4 pi. And so I'm going to be ending at 11 pi thirds. Okay, so I'm going to be starting at negative pi thirds and ending at 11 pi thirds. Okay, so let me get that situated on my graph. Okay, so I drew in my negative pi thirds and I drew in my 11 pi thirds. Okay, so I counted them. And I do not have a vertical shift. So that's going to be here like that. Okay. And I'm going to be starting at negative pi thirds and ending at 11 pi thirds. And I do have an amplitude of 4. So what that means is I'm going to go up 1, 2, 3. My highest is going to be up at 4. And 1, 2, 3, 4. My lowest is going to be down at negative 4. Okay. So now I'm going to plot my points. So again, I'm going to be starting at negative pi thirds, ending at 11 pi thirds, and then halfway in between, which this is going to be distance of 12 of them. So I'm going to go over 6. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So that's halfway in between. And then halfway in between these, okay, I'm going to be up at 4. So 1, 2, 3. 1, 2, 3. So halfway, I'm going to be up at 4. And then halfway between these, I'm going to be down at negative 4. So 1, 2, 3, down at negative 4. And I'm going to connect these. And there's my sine. Okay, and let's see. Our next one, we have a 4 in front. Okay, so if I have a 4 in front of this, this is going to be affecting the period. So my amplitude is still going to be 1. My vertical shift, I don't have any. The period again is going to be 2 pi over 4, which is pi halves. Okay, that's how long it's going to be. And my phase shift, I'm going to be starting at negative pi 6. So let me just do the math up here. So I'm going to be starting at negative pi 6. I'm going to be adding pi halves. And so let me just change this. This is going to be a negative pi 6. This is going to be 3 pi 6. So I'm going to end at 2 pi 6 or pi thirds, but let me just count it as 6 so that way I can kind of just space it out. So I'm going to be starting at negative pi 6 and I'm going to be ending at 2 pi 6. Okay, so let me get that drawn out. Okay, so I'm going to be just spacing this out. I think I'm just going to space it out this way for this. Okay, I'm just going to have this so it's not so scrunched. This be negative pi 6. Let me write this smaller though. So this will be negative pi 6. This will be pi 6 over here. Do this, get this one a little fatter. Okay, so this will be my pi 6, and then this will be my 2 pi 6. Okay, so I'm just going to space it out a little bit. Okay, and then here, that's at our 0. So that's our 1, 2, 3, 4. Okay, and then so pi 6, 0, pi 6, 2 pi 6. Okay, let me just label them. So this is pi 6. This is 2 pi 6. Okay, I'm just spacing it out, making it a little wider. Okay, and I have no vertical stretch, so this is, or shift, sorry. So it's going to be here. Right here. Okay, and then let me plot my points. My amplitude is 1, so I'm going to be going up 1 and down 1. I'm just going to kind of space this out. Okay, I'm just going to have this be 1 up, this be 1 up, and this be 1 down, just so I have a little more space. Okay, so now I'm going to be starting at, this is my 0, this is my 0, my start and my end. Halfway in between, so halfway in between here, here, so I'm going to go halfway here, so I'm going to be right here at this, and then halfway between these, I'm going to be up at 1, so let's see, that would be around here. Okay, again, just halfway, and then halfway between these, okay, so here, here, so halfway in between these, I'm going to be down here, and then I'm going to connect these. And that's my graph. Okay, just kind of spacing it out. Obviously, if I did pi 6 really tiny, I could just spacing it out so we can kind of see the flow of the graph. Okay, so next one. Okay. So this one, we have a -3 in front, so we have to be careful with that. Our amplitude is going to be 3, but again, it's a -3, so I'm going to be starting down after my 0. My vertical shift is going to be 1. I'm going to be going up 1. Now this 6 here, you can factor out the 6. I should just keep that 6 in here, okay? But you could factor it out. If you factor it out, it would really be 6 times x plus pi 6. So you can do it, and you can see that's a 6. You can just leave it. So usually what I do is I usually just leave it, and then I just say, okay, well, 6x plus pi equals 0. What makes that 0? And then I just solve. And when I solve, I get 6x equals negative pi. And so x equals negative pi 6. So that tells me my phase shift is negative pi 6. So I usually just leave it like this. You can also factor out the 6 if you want. But whether the 6 is in the parenthesis or outside, it's in front of the x, it's going to affect your period. So that means I have 6 cycles within a 2 pi distance, okay? So this is going to be 2 pi over 6, which is pi thirds. Now, if I want to figure out where I'm starting and stopping, okay, let me just do it in black. So I'm starting at negative pi 6. I'm going pi thirds, but I'm going to keep it as the 2 pi 6. So I'm going to end up ending at pi 6. Okay, so I'm starting at negative pi 6. I'm ending at pi 6. Okay, so I'm just going to space it out again. So let's say that that's and that. So this is going to be, let's say, negative pi 6. I'm just spacing it big. And this is going to be pi 6. I know I'm going to be starting up at 1, and then I'm going to be going 3. Since I have to go 3 above or below, I can't really adjust my y that much. So what's going to happen is I'm going to have this be my center, and then I'm going to go up 1, 2, 3. So I'm going to be at a height of 4, and 1, 2, 3. So I'm going to be down here at -2. So again, I want to see my middle, my high, my low. And let me draw in my vertical shift. So I'm right here. This is where my vertical shift is. This is where my zeros are. And I'm going to be starting at negative pi halves. I'm going to be ending at positive pi halves. Halfway in between is my other 0. And then halfway in between those, in this case, I'm going down first. I'm going to be down at -3 below, which puts me at -2. And here, halfway in between these, I'm going to be 3 above, which puts me up at 4. And there's my graph. Okay. Now, the next one anytime you have a pi in front of, as your b, okay? Anytime you have a pi as your b, the number in front of your x, that means I'm not going to scale this by radians anymore. I'm going to actually scale it by normal numbers, okay? And you'll see why here in a second, but that's always going to be the situation. We're going to get normal numbers back. So my amplitude is 2, okay, but again, it's a -2, so I'm going to be starting going down. I don't have anything here that's going to be adding or subtracting, so this is none for vertical. Now, again, this 2 pi is in front of my x. So it's 2 pi divided by 2 pi. So my period is 1. Okay, my period is 1. And my phase shift, okay, my phase shift, I am going to be starting at, and let's see, so let me set this. Again, either I can factor out the 2 pi or I can take 2 pi x plus 4 pi equals 0. When I do that, I'm going to get 2 pi x equals 4 pi. I'm going to divide by x, and by 2 pi, and then when I do, I end up with 2. So I'm going to be starting at 2 and ending at 3. Okay, that's what's going to be happening because my start is going to be at 2, but then 2, my start plus my period 1 means I'm going to be at 3. So I'm going to start at 2 and end at 3. Okay. So let me just kind of get my graph situated here. So let me get black. So I'm going to be starting at 2 and ending at 3. Okay, that's kind of that's where I'm going to be. And my vertical shift is none, but I know I'm going to be going up and down 2. So I'm going to be at 2 and -2. And again, let me draw in my vertical shift. Okay. So this would have been 1. This is 2. This is 3. Okay. So I'm going to zoom in a little bit. Okay. And for my graph, since I got a lot of red there, I'm going to do it in purple just so we can kind of see it. I'm starting here. I'm ending here. Halfway in between, which would be maybe about here, I'm going to be at 0. And then halfway in between those, okay, which is maybe about right here, I'm not going to go up. It was a -2. Okay. So I'm going to, it was a -2. Let me just remind us it was a -2. So I'm going to be going down 2. Okay. So in between, halfway in between these, again, I'm just going to approximate halfway just looking at it. And then halfway in between these, again, just approximating. And there's my graph. I'm going 1 unit for my whole sine. And anytime again that your B has pi in it, you're going to have normal numbers on your x-axis. Okay, so last one. Okay, so you'll notice that again, I have a pi here. So this one is also going to have normal numbers here. Okay, my amplitude is 1. It's actually negative, so I have to be careful with that. My vertical shift, none. My period, let me just do the math up here. It's going to be 2 pi over 2 pi thirds, which is 2 pi times 3 over 2 pi, which means my period is 3. Okay, so it's going to be 3 units long. What makes this 0? 0. So I'm going to be starting at 0 and ending at 3. Okay, so I'll be starting at 0 and ending at 3. So I'm going to start here at 0 and end here at 3. And my vertical shift was none, so I'm going to be here on my x-axis. Again, I'm going to be starting at 0, ending at 3, and halfway in between, okay? And we're just going to approximate that. So that would be 1.5. Okay, so let's say about here, just approximating it. And then my halfway in between there, I'm going to be going down 1. So halfway in between this, again, just approximate it. And let me just put my, I'm gonna space it out a little more. So let's say that this is 1 and this is -1, just to get a little more space to the graph. Okay. Okay. So halfway in between here, I'm going to be down here at -1, and halfway in between here, I'm going to be up at +1, and there is my graph. Okay. So remember, when you're doing the worksheet tonight, if you get stuck, you can use that trig function Desmos, but I do want you to try to do it without, and then double check on that and see how you're doing. Good luck.